This one is Geometry, Semester 2. It's the 5th unit, Circle, Angles, Arcs, and the 4th lesson, Tangents Practice. It's on creatormath.com under the Geometry tab. Copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages. Those are on a separate link on the table of contents. Open those up and put them on the right pages in your comp book. And it's from creatormath.com under the Geometry tab. Well, so with angles and arcs and circles, we have certain things. Let's start with a circle. Let's do some review. Here's the center of the circle. A circle is the set of dots an equal length from the point called the center. So if you measure this length all the way around and then circle around that point, right, or rotate around it, or put dots down, the set of those dots will form the circle. So this is the circle here. My pen is on the circle. This area inside is not the circle. It's area inside the circle. So there's a radius. Radius is from the center to the side. Sometimes you can use a word like rat. A rat is a small animal compared to, we used to say D for diameter or dinosaur. So dinosaur, D was the larger dimension from side to side of the circle. The radius is from the center to the side. You have things like chords. The chord goes from side to side, not through the center, and it's spelled chord, but we pronounce it chord. There are secants. Secants extend out from one side past the other, and we'll often use them in pairs like this to form an angle here. We'll do some fun things with the inner arc and the outer arc and the angle here. Then there's this thing called a tangent. A tangent literally is a line that touches the circle, so it's touching, but it is not crossing over. So it's not in here and it's not out there. It's right on the circle. And where it touches right here, it is at a 90 degrees to the diameter or the radius right here. And that's called a tangent. Right? Now, tangent, where it's a line touching a circle, is different than the tangent function in trig. We've covered tangent functions in trig. Don't mix up the two. They're not related. They're the same word used for different circumstances. So let's see. Given the following tangents to a circle, if C is 270 degrees and B is 90 degrees, then what is the remaining angle measure? Hint, the formula used is A, so the angle here, A, is equal to C minus B, this larger arc, minus B, this smaller arc, divided by 2. I don't know if you can see the 1/2 in there. Yeah, you can see it. So, interestingly enough, if this tangent was drawn right here, right, it's touching the circle. If there was a center, you'd have a line or radius extending here, segment called radius. It would be at 90 degrees to this tangent. You'd have another one going this way, a radius, and it's touching here, the tangent at 90 degrees, also producing interesting situations, which we'll cover later. For now, they're asking us about arcs. Arcs are when we talk about the outside of a circle. This is an arc. There's an angle, so for example, the angle from here to here is called a central angle. This is called an arc outside. Inevitably, one of the arcs will be larger. The larger arc is called the major arc. Again, you're looking at the notes for this section on that separate tab in the table of contents because it explains most of this, but I'm just going to reiterate a little bit. This smaller arc is called the minor arc, and that should make a little bit of sense to you. The larger one is major. The smaller one is minor, which is what major and minor mean, bigger and smaller, right? So there's a formula for this. There's a couple formulas. The entire dimension they give us, this C out here, plus this B have to equal 360 degrees. And notice that they give us 270 and 90. If we add those together, we do indeed get 360 degrees. That's important. If that's not right, then this whole thing doesn't work very well. And we can find this angle out here by taking the larger arc minus the smaller, dividing it by 2, and we'll get this one in here, which, by the way, was the same setup we used when we had two secants. We had an arc here and an arc here. By taking the larger minus the inner, dividing it by 2, we came up with this angle. It's the same situation if they're tangents, right? Let's see what they are. What are they asking for? What's the remaining angle measure? They must mean what's A? I think that's what they mean. So let's take 270 minus 90. 270 minus 90, let's divide it by 2, and we'll get A. All right, 270 minus 90. 180 do we get? 180 divided by 2 is 90 degrees. So we have A equals 90 degrees. And that's when this here. So notice the drawing isn't drawn very well. It's probably drawn more like this. For you to get that kind of 90-degree angle, those tangents would be more like that. But we don't need the picture drawn to scale to go ahead and complete the computation. All right, same one. Given the following tangents of a circle, C equals 300. So this larger arc, 300 degrees. 300 degrees. This smaller arc, inside arc, 60 degrees. What's the remaining measure angle? What's A over here? Well, we're going to say A equals the larger, 300 minus the smaller. And let's go say the major minus the minor divided by 2. 300 minus 60 is 240 divided by 2 is 120. This equals 120 degrees. This is in here. Okay, that would be this right there. 120 degrees. So not very complicated in terms of computation, but it's always difficult for my brain to see how, circles seemingly are very interesting for my brain to grasp just because of this constant curvature, right, that comes around. It's an amazing shape. Given the following tangents to a circle, if C is 300, okay, this is 300, then what is the measure of B? This equals X, all right? What is the measure of B? Well, notice that the total of this has to be 360 degrees because it's a whole circle, and the tangent right here is touching only at a point. It does not take up any of the arc, in other words, because a point has no mass and doesn't have any existence other than a location. So if this is 300, this has to be 60 to get 360 for the total circle. And what we're really looking at, if we really wanted to go through the rigmarole, we would say C equaled 360 minus B. C, we said, is 300. So 300 equals 360 minus B. And that's way more complicated than it has to be, and I don't even want to use equation solving on it. What does B have to be to subtract from 360 to equal 300? B has to be 60. And it would be a lot easier for me just to say the total has to be 360 and I got 300. B is 60. So this one's interesting. I already did it over here a little bit. Let's rewrite it for us. Let's see if we can get some space here. So let's use our normal relationship here. We've got the outer arc at 360 minus x. We're going to subtract from that the inner arc minus x. It's going to equal the measure of our angle out here, 50 degrees. So now we do have an equation. We have 360 minus 2x's. Minus x is minus 2x's, which now equals 50. Now this one, let's do some equation solving. Let's subtract 360 from both sides. Or rather, let's add 2x to both sides, just to keep the x's positive. So now we have 2x plus 50 over here. Equals, we're keeping lined up. That's our center line. This is the left side. We've got still 360 here. Let's subtract 50 from both sides. Two x 50 equals 50. Let's see here, minus 50, we're left with 2x, okay, line, 2x, sorry, I'm getting distracted. This is 310, divided by 2, equals 360 minus x, minus 2x, equals, oh, you guys, I forgot, I'm sorry, you guys. I'm like, what am I doing wrong here? You've got 360 minus x, we forgot, divided by 2. There we go. Now I'm happier. I'm like, I'm not very happy right now. All right. Multiply both sides by 2. And 2's are gone. 360 minus 2x equals 100. There we go. Add 2x to both sides. 2x plus 100 equals, gone from here, 360. Subtract 100 from both sides. 2x equals 260. There we go. Divided by 2, divided by 2. The 2's are gone. X is equal to 130 degrees. So in this case, this arc here is 130 degrees. This is 130. This is 360 minus 130. Okay, so 230. This one over here will be 230. Okay, and 50. And that all plays out. So what they're actually asking for is this one in here, 130. Right? Sorry to get so messy on you there. Apologize for that. Still kind of fun. All right, so this is match up this assignment name with the table of contents on creatormath.com under the geometry tab to make sure you're in the correct video matched with the assignment. And you're matching that with the notes and putting it on that page in the comp book.